Welcome to North Point High School's Wearable Technology presentation. Introduction of team members and description of roles. Kayla Barrow was in the 12th grade and was responsible for researching, designing, programming, sewing, and the final report. Danae Hudson in the 10th grade was responsible for researching and designing. Nathaniel Hill in the 10th grade was responsible for researching and designing. And Brianna Edwards was in the 9th grade, and unfortunately we did not have a picture of her, and she was responsible for researching and designing. We did research related to other devices with the same use and different methods for measuring the respiration rate. We also researched the definition of the respiration rate, which is the number of breaths a person takes per minute. The rate is usually measured when a person is at rest and simply involves counting the number of breaths for 1 minute by counting how many times the chest wall rises. And this is based on Hopkins medicine. We had to know how to measure the respiration rate, how to code, and what materials would be best for the device in order to be successful. First, we established what we wanted the device to look like. The idea we had in mind was inspired by Iron Man, so we wanted to make a shirt with stretchable fabric so that it could fit babies of varying sizes and be washable for any stains that may be on it. Next, we had to establish how we wanted the device to function. In this case, we knew we wanted to use an accelerometer to measure the respiration rate based on the movement of the chest wall. After that, we figured it would be easiest to make a pocket so that the device can be inserted and removed when needed. We picked out an appropriate fabric and sewed a shirt out of it. Finally, after research on coding and the accelerometer, we were able to make our own version of the code for the device. We tested the design by putting the shirt on the baby and the device in the shirt and then pumping air into the neonatally to represent the respiration rate. We had to figure out the value of the C direction after one respiration and program the code around this. This value happened to be 10. We counted the number of respirations in 6 seconds, then multiplied it by 10 to find the respirations per minute. We added an additional section to the code that allowed the device to beep every time a respiration was registered. This is similar to the devices that patients are hooked up to in hospitals. We ran into a few obstacles along the way. The circuit playground stopped connecting to the computer, which meant that we could no longer test our device. But after troubleshooting, we were able to make it work again. This meant that for a while, we had to code without being able to test the code. Another issue we ran into was trying to develop the code because none of us had ever had experience with doing this before. And we overcame this by looking at videos for code.org and the Circuit Playground, along with lots of trial and error. The key element of our final design involves a shirt with a sewn-in button-down pocket along with the Circuit Playground Express. In order for the design to work, the Circuit Playground Express is inserted into the pocket and then buttoned to be secure. And then it is positioned such that when the baby respirates, the accelerometer will measure it. The accelerometer measures the change in the Z direction, which is the movement of the chest wall up and down. The code displays a value each time the chest wall moves. Simultaneously, the code has programmed the sound to play each time this happens as well. And the lights will change colors accordingly. This can be plugged into a computer or anything with a USB port and can be up to 36 inches away. Considering ergonomics, we made sure that the baby's shirt was made out of a cotton full-way stretch fabric such that it can adjust to smaller or bigger babies. This one happens to be more of a preemie sized baby, so it was made small, but it has a lot of stretch in it to fit larger babies. This one was specifically made to accommodate the neonatally, which has an umbilical cord and cords for respiration. So it has holes in it for those, but the actual design for a baby would not have these holes. We made sure that the fabric for the shirt also involved lycra so that it could stretch. We decided to make a shirt because we thought that a removable aspect would allow for any stains from the baby to be washed out, and then the device could then be reinserted for use later, which would make it easy for the parent or doctor to clean. Here is a video showing that the USB connected to show the data goes at least 27 inches away from the baby. This is a picture showing that the circuit playground can be powered by a battery pack, and this is an image of our group's code. When it is time for the parent or caregiver to place the shirt on the baby, you first pick it up and place it over the head like any normal shirt, this being the head hole. See, the fabric has a large stretch to it so it can accommodate any size baby because babies tend to have larger heads. It may not look comfortable, but I assure you it is. Then you slide the shirt down continually. Place one arm through the armhole. Another arm through the other armhole. Slide down. In the case of this baby, we want to make sure that the umbilical cord goes through the hole. And the openings for the cords go through the side hole. And then pull and adjust accordingly in the back and the front. When it comes time for inserting the device, we simply open it up, put it through the pockets, and button the shirt back to fasten it. And then the device is secure. In order to start the application, you first push run. Next, if you click on respiration rate, it will set the base acceleration value to 0. The resting acceleration value, although for the baby, once it is calibrated, will change to 9. It takes a few respirations for the actual value to change to 9. Now the resting acceleration is set and there's no respiration happening. You can see that on the phone, the acceleration value is 9. After you start the respirations, after all the respirations are calculated, you can now see that the reported respiration rate was 78 respirations per minute. This means that the baby respirated 7 times approximately within 6 seconds, and this was used to calculate the overall respiration by multiplying by 10.